How's it going, guys? It's Jiggy here, and in this video we're going to be covering something called function composition. We'll be taking a look at how functions are combined and the mathematical notation for it. So let's get started. A key concept in functional programming is the ability to have a complex function which is formed by combining several simpler functions. As each simpler function runs and outputs its result, this is then passed in as an argument to the next function. This continues and continues until the final result is produced. Let's have an example. Suppose you wanted to scramble some eggs. We can think of this as a series of smaller functions whereby the output of one function is used as the input for the next. Of course, as you can see, our first step is to crack the eggs, which would of course result in a cracked egg. Our next step is then to add milk to the cracked egg and beat the mixture, which will result in a whisked egg. And finally, we'll add this whisked egg to a pan and cook until it's ready, which will of course output our scrambled egg. So you can see how all these smaller functions eventually snowball into a more complex function. Each function takes the output of the previous function as input for itself in order to complete the overall function of making scrambled eggs. This is all made possible through a concept called function composition, which is where you can create a new function by combining two existing functions. Let's apply this to a mathematical context now. We're going to have a function called f, like this one here, which will map a value from domain A to codomain B, and we're going to combine it with a function called g, whereby B is the domain and C is the codomain. Now you may notice that B is used in both functions. That's because the result of f is taken in as the argument for g. So in f, B is the codomain, and in G, B is the domain. Functional composition is of course where we can combine two functions. We'll represent G and F being combined like so. That little circle you see there is a symbol that says function G is combined with function F. So let's go ahead and have a mathematical example now. Let's say f of x is x plus 5, and let's say g of x is x squared. So let's pass in 3 as our argument for f of x. We'll then have f of 3 is equal to 3 plus 5, which of course is going to give us 8. Now, as we said earlier, whatever the result of function f is going to become the input for function g. So what we'll do now is pass in 8 to the function g. This means that g of x is equal to x squared becomes g of 8 is equal to 8 squared, which of course is 64. We can hence express this notation here as g of f of x, since the argument for g is reliant on the output of f. And we're done. Let's have a recap. Function composition is where we combine functions in order to make a more complex overall function. The output of one function is used as input for the next, and finally, let's remember our mathematical notation.